Okay, everybody, you're more than welcome here this evening to Newford Farm. As Martina said, my name is Michael Fagan, and I'm going to take you through the sustainability initiative stand here. I was 6 or 7 years here in the farm here before I transferred up to Grange. There was a few steps that we started putting into place, but I suppose the big wake-up call came here for the farm when the fertiliser prices shot through the roof last February and March, when that 1,100 euros came home. It made the farm here cop on, what are we going to do? There was an awful lot of emphasis too on the environmental. Farms had to start improving their environmental. So what we did is, we said, right, let's look at Clover. What did Clover do for us? It will actually reduce our costs, and it also reduce our emissions. So this paddocks, all these paddocks here on the right hand side is covered in red. We decided we'd oversow them. This paddock that you're in at the moment has not been oversown yet, but you can see the clover in it. There's about 10 to 15% amount of clover in here. If we oversowed it, which maybe we'll see as how the programme goes along, get in next year, we will hopefully get that up to 30%. So when you're oversown, we target the month in April. We send the cows into the paddock. We make the cows and calves, mainly the cows, to graze the paddock really, really tight. When the cows come out that day, we have a 6 metre time box harrow waiting to come in. The protocol is when the harrow comes in, we open up all its arms, spread out the tines. The driver then goes sideways on the paddock, and then he goes up and down the paddock. We do that process twice. The idea is we're trying to scrape or tear the soil. So on the third time, we put the clover into the hopper, and when the clover goes down to the hopper, it will make contact with the soil. And that's the reason why we tear the soil, to make contact with the clover. The clover is so small. The other key point you have to bear in mind, and you have to get this right too, your paddock must have a pH of 6.3 or 6.4. Otherwise, you're only wasting your time. Where we would have done our soil testing, we'd have seen our paddocks maybe 5.8. If there is any of those, we would have given them lime and oversown it the following year. I said to you that we target the month of April. We target for another reason. In the month of April, the soil is a little bit more moist, the temperature is beginning to grow or pick up, and the sunlight is a bit more longer. But also the other key point it has to bear in mind is when the little clover takes root, the two little leaves starts coming up. It is in the month of April. It gives it a chance to compete with the growing grass in April. If we were to do it in May, June or July, the grass cover is way too fast, and the little clover seed would get smothered. So in the month of April, the grass growth is a little bit more slower. It gives the clover a chance to come on. It does give it a chance to come on. And then the key point is we go in at around 800 kilos with the cows again to graze it down. Not tightly, just to give it a reasonable good graze out. Enough to give the clover there to be established, enough so the cow wouldn't pull up the roots of the clover. And then the second time the cows goes back in will be around 1100 to 1200 kilos of a grass cover. And that is the key point. Every time to go in, it has to be no more than that, because clover needs light, and if there's no light, the clover will just fade out. The other key point here on the farm here is that we put in place here is Newford is part of the Future Beef Farms. This is their target, but I'm just going to zoom in on what we are doing here on the farm. The maternal index here for the cows here on the farm is 139 euros, or the Eurostar. All our cows replacements came off the dairy herd as Angus/Herefords first cross. It is the milk that's in those that's driving up that figure up to 139. It is the milk in those that pushes on the little weanlings, or pushes on the little calves into weanlings, and it sets them up into a good weight gain for the winter period. The 6-week calving rate. As I always said, I'm pro Angus and I'm pro the Hereford cow. She does exactly what she says on the can. She's a nearly maturing cow. She calves down in February. She minds the little calf. We turn them out around St. Patrick's Day, give or take, she begins to start cycling. And by the time we start the breeding season at the end of April, nearly all them cows are already bulling. And the key point there is on those early maturing breeds is, if you're trying to sell the bullocks or the heifers the following autumn, that 3 weeks when them cows have gone back and calf in the month of May, we will have saved that 3 weeks by no cows slipping, by able to sell off the little beef heifers off grass in the months of July, August. No need for a second housing for the vast majority of them. Some of the bullocks will be housed all right, but we will have a portion of them gone as well. So that 6-week compact calving makes an awful difference. Improving the 200-day weight. The future beef are targeting 275 kilos plus on their herds. We're achieving 315, and how are we doing that? It's got to do with the milk that's in the cows themselves. The little bull cow, they're squeezed. The male cows are weaned at about 328 kilos last year. They did an average daily gain of 1.35, and that's really coming from the bulk of the milk from the mother. And the heifers are weaned at 1.32. Silage quality, 74% DMD. I would like to get it up a little bit more, but you must get that right, which we have achieved here. And as Martina said, is the key point, I think it's big time, we're no different than year farms. Like what we're doing here, you can bring it home. Like silage quality, we graze the silage ground. We close off around the 12th of April. We cut it, okay, because the open day is on this week, we probably would have a cut by now, but normally around the 22nd of May, the silage is cut, 24-hour wilt, and then we get to achieve the 74% DMD. What that means is we have less ration to be given out to the bullocks and less ration to be given out to the weanlings. Soil pH, that's something that, look, when you do your soil testing, you do need a pH of 6.5. When your pH is right, when you spread your fertiliser, the nutrients in that soaks up, the roots will soak up all that nutrient and grow your grass. If your pH is only 5.8 and you're spreading fertiliser, you're not getting the same buck for your bang, and it's costing you money, it's costing the environment. The last little bit there on other measurements, CAN. Look, we were like you all using CAN, we've transferred back over onto protected urea, and it does exactly what it says on the can. It's easier in the environment, and it's the same thing as the can itself. Splash plate. We're now using the low emission slurry, shoe and tail, just keeping the no emissions being spread up into the air. And the last thing here is what we do, we get the vet out around every January around the 10th or 12th. We sit down, we go through our herd health plan, we see was there any issues last year. If there isn't, we'll implement the same procedure again this year. The big thing is here, when you have a herd health plan in place, your vaccination of your calves, you don't let your animals get sick, and when your animals are not sick, you'll get them out the gate an awful lot quicker and a lot more healthier.
Yeah, so hello everybody, thank you for coming. My name is Jonathan Herron, I'm a researcher in Teagasc, and I'm just building on from what Michael talked about, as Martina said, and looking at greenhouse gas emissions specifically. We know I get a lot of press at the moment, agriculture, and the reason behind this really is the fact that it does take the large share of our national greenhouse gases, 37% as of last year, around that. The target, regardless, that has been set to the agriculture sector by the government is 25%. It's a sector-wide target. To achieve that, each individual farm has to start adopting the available technologies and the best management practices that we can to achieve that. Now, we're focusing on economic viability. It's very, very important. The first board that you talked, you've seen Paul Cross, you've seen Pork French, that is the message, that's the focus. But what we need to do is nearly a double whammy. We need to improve economic viability while also addressing the target that's set to us in terms of greenhouse gas emissions, okay? Where are they coming from? The vast majority comes from methane, okay, so that's enteric fermentation. Vast majority just comes from the cow digesting feed. A small proportion of that is lost as methane. It's a potent greenhouse gas, and it takes the lion's shares of our national greenhouse gas emissions. Similarly for agricultural soils is your fertiliser that's spread. It's also the urine and dung that's excreted when the cow is grazing. And then you have manure management, and that is how you handle your manure, how you storing it, and how you spreading it essentially, okay? There are greenhouse gas emissions from cattle systems. We know what our target is. To achieve that target, we need a benchmark, we need a baseline, so we need to know our starting points. So we worked with Michael and the team here in Newford to, I suppose, paint the picture of the Newford Farm using the data that they're recording here in terms of animal performance, as well as what meal you're buying, what fertiliser you're buying, what type of fertiliser you're buying, all them kind of things. Building a picture of a farm to basically how is this system any different to the next beef system, okay? What we see here is that the average carbon footprint for a beef that's produced on the Newford Farm in 21 was 19.5. So that's per kilo live weight. So 10.5 kilos of carbon per kilo live weight produced on that farm. Going to 22, that's reduced by over 5%. And how that was achieved is primarily that top row, okay? It's the heifer age of slaughter. So going from the 20 months of age down to your 18 months of age at slaughter, What that essentially means, that animal achieved a similar carcass weight of 300 kilos, but in a short period of time. Okay, 60 days less than that of 2021. So that animal is working harder for you. That animal also doesn't go into a shed. She's getting more live weight off grass. Grass is the cheapest feed that you have available to you, but it's also one of the most environmentally sustainable feeds that we have available to us, rather than going with silage and going with your concentrate feed that's imported from all around the world. Okay, homegrown forage is the message there. Protected urea, going from 84% to 100%. So Newford was already a top performer when it looks at protected urea, but going to 100%, that also helped to reduce your greenhouse gas emissions. It's significantly less nitrous oxide than that of your can. So Michael mentioned that previously, going from can to protected urea. Clover, okay. So first of all, you need to get the ground right before you go with clover, as Michael talked about. But what clover does is basically it fixes nitrogen. It takes nitrogen from the atmosphere, brings it into the soil, and then you're displacing that fertilizer. So you need less fertilizer so it's to grow the same amount of grass. That's going to be economically beneficial, as well as your agricultural soil emissions. Okay. The last one then is your less. Okay, and what the less is looking at is you're improving the fertilizer value of that manure. Okay, less of that nutrient is going to be lost to the air. Therefore, more is in the slurry. More is going to be taken up by the grass. You need less fertilizer. That's saving you in money terms, but it's also saving you here. And then age of slaughter. Age of slaughter, similar, it's going to be talked on the next stand, but it's primarily due to that animal starts working for you in an earlier time. So there's less time that animal is on the farm not being productive. You're reducing that time period by going to the 24-month calving. Newford is a top performing farm in terms of the average system, which is killing bullocks around 28 months of age. So it's 20% lower. Even at that, it still had room to improve, a 5% reduction in emissions. So there is a lot of low-hanging fruits that we talk about today that farmers can look into trying to put into place onto their farm. Age of slaughter, age of calving, fertiliser, and fertiliser type and clover. They're the main things.
So my name is Rachael Murphy. I'm a researcher here in Teagasc. I just kind of want to maybe firstly build off the point Jonathan was making there regarding our emission reduction targets. So by 2030, Ireland nationally has to reduce its emissions by approximately 50%, and by 2050 we need to be achieving net neutrality. So that's quite challenging, and when we actually look at the breakdown of emissions from the agricultural sector alone that Jonathan provided an overview of, it's very, very challenging for the agricultural sector and for farmers. And so what we really need to do is really know and understand, what is the carbon sequestration potential of our pastures, of our agricultural soils, and to really understand those numbers and what managements help to promote sequestration, and how that might change over time with a changing climate. So what we really need to do then is, how do we measure and how do we quantify what our carbon sequestration potential is of our pastures? So if you just turn your heads there to the left, you can see what is an eddy covariance flux tower. So this is an instrument that we're very interested in using here in Teagasc and on Newford to quantify the exchange of CO2 or soil carbon emissions along the atmosphere, vegetation and soil continuum. So this method, this technique is very interesting because it works at really high spatial and temporal scales. So it takes 10 measurements every second, and that's block averaged over 30 minutes for every day of the year. So you get really high temporal resolution data, but also covers a really large spatial domain too. So typically this tower will record, for every 1 meter high it'll measure about 100 meters surrounding it. So you really do encompass, our emissions at the field scale. So you see like a really clear picture of what's happening at your field. So I guess, what does the data from this instrument look like then? So we just have some graphs here from work that's been done in Johnstown Castle. So our tower here in Newford is quite new, but in Johnstown we've had towers running for nearly 20 years. So we have a lot of long-term data there. So this is just to show you what the sort of data looks like in terms of capturing these temporal and spatial dynamics in our CO2 emissions. So in Johnstown Castle, it's a mineral soil dairy grassland system that this data was measured from. And what the colours show you is differences in uptake, which is your negative numbers, and emissions, which is your positive numbers. So your uptake is typically from photosynthesis, so how plants capture carbon from the atmosphere. and your emissions are typically associated with soil and plant respiration. So the sort of dark navy numbers and the green represents your uptake, and your sort of yellow and orange numbers represent your emissions or your respiration. So on your y-axis there you have the hour of the day, and on your x-axis you have your day of year. So what we see in these graphs is really like a very distinct shape. So at the beginning of the calendar year and towards the end of the calendar year, so in your winter and your spring, you see that the curve is quite narrow. So you're seeing sort of like a narrow range of uptake and release. And that's really because it's the beginning of your, well, not really the beginning, it's just before the growing season, where plant and biomass productivity isn't at its peak because you don't have the weather for it. And then as we come into like the summertime, you're seeing a lot more uptake. So again, that sort of navy green colour. So you're seeing that the pasture, the plants are capturing more carbon. So that's sort of like showing you what the weather and how it can implicate and affect your CO2 uptake and release. But what we also see is sort of like blotches of the changes between the navy and the green. And that's really showing you what the implications that management then has on your CO2 dynamics. So in the system here, you're seeing more of like a sort of a sawtooth pattern where it's quite up and down and spiky. And that's symbolic of what would be like a strip grazing system, where when cattle come into the pasture and they graze it and they move on to the next strip in that pasture, the system's constantly regenerating itself. So you don't see this massive sort of drop off or reduction in your CO2 uptake. Whereas in, for example, an arable system where you might come in and you might harvest your pasture and you get a massive sort of loss of biomass through harvesting, and you're removing all that carbon or that biomass from your system, you see a kind of a drop and reduction in the magnitude at which you're seeing CO2 uptake. And so what this is really kind of just to show you, like to summarize, is just how this method, eddy covariance, can show you how your CO2 changes over the course of the year, be that depending on the season or depending on the management that your pasture is under. So I'll now move you over to Dan, who'll talk more about the green feeds and methane emissions.
Hi everyone, I'm Daniel Flynn. I'm a research technician based in Teagasc Grange, County Meath. So I suppose my role here on Newford Farm is looking after this machine over here. So MTI, Meat Technology Ireland, and industry members have come together to look at a project at reducing the age at slaughter, and one segment of that is a methane profile. So methane profiling as many cattle in Ireland as we can. So it's a 4-year project. We're looking to do around 7,000 over them 4 years. So basically I'll talk a bit about the unit next. So the unit itself, it's like a feed hopper with the capability of measuring enteric emissions. So it can measure methane, it can measure carbon dioxide and hydrogen. So how it works is when an animal enters the feed hood, an EID reader reads its tag and knows whether it's been in or not for the last 4 or 5 hours. If it hasn't, it can come in and it'll get 30 grams of concentrate. So this just entices the animal to stay in the green feed unit. And at the very top there's a fan which creates an airflow. So this airflow draws up the breath of the animal, which can go through a sample intake line, which then goes through various sensors, and this gives us grams per methane per day after a lot of calculations are done. So the point of this project is, as I said, lowering the age of slaughter, but also getting a methane profile for Ireland. So this can vary, like there's a lot of work being done in feedlots or at pasture with dairy base, but this is going to look at sucklers and beef progeny. So methane per day can vary on grassland management, on breeding indexes, on breeding plans for farms. So this is all going to be taken into account over this 4-year period.